E-Chemistry class presented by Fatima Convent High School, myself Dipali. Chapter 2, Acids, Bases and Salts, Class 10. In today's session, we are going to understand how strong are acids or base solution, and what is the unit or what is the measurement scale for measuring the acidity or basicity of any substance? Now we know that how acid and base indicators can be used to distinguish between acid and base. We also have learnt in the previous section about dilute and decrease in concentration of H plus and OH minus ion in the solution. Can we quantitatively find the amount of these ions present in the solution? Can we judge how strong a given acid or a base is? Yes, we can do this by using a universal indicator, which is a mixture of several solutions. The universal indicator shows different colors at different concentration of hydrogen ion in a solution. A scale for measuring hydrogen ion concentration in a solution is called pH scale. It was developed by a German scientist. Now, the P in the pH stands for potentiation in the German meaning power. On the pH scale, we can measure pH generally from 0, where acidic, very acidic, to 14, very alkaline, that is basic. So, pH simply stands for power of H plus ion. Now, pH should be thought of simply a number which indicates the acidic or the basic nature of the solution. Higher the hydronium ion concentration, lower is the pH value. The pH of neutral solution is 7. The value less than 7 on the pH scale represents acidic solution, and the pH value increases from 7 to 14. It represents an increase in OH minus concentration in the solution, that is, increase in the strength of alkali or the base. Generally, paper impregnated with universal indicator is used for measuring pH. You can see the pH scale here, where we can see the neutral scale at 7, and from 0 to 7, as we move, it is acidic nature increases as you go from 7 towards 0. And as you go from 7 towards 14, the basic nature increases. So, we can in general say that the pH is a scale for measuring hydrogen ion concentration in the solution, and the pH scale ranges from 0 to 14. In general, the higher the concentration of hydronium ion, higher is acidity and lower is the pH value. And lower the concentration of hydronium ion, lower is acidity and higher is the pH value. Now you can easily give an equation to represent this. So, in general, if we write pH, that is power of hydronium ion, plus power of OH minus is always equal to 14, and pH is equal to minus log 10 H plus aqueous. You will study this in higher classes, but you can remember the formula of pH and POH as this. So, if we summarize this part, we can say that pH value, higher the concentration of H plus, if it is high, then acidity is high. And pH value is low. And concentration is low, then acidity is low and pH value is high. This is how you can remember. And pH ranges from 0 to 14. And 7 is neutral, where it is nor acidic nor basic. And if you go from 7 towards 0, it is acidic. And when you go from 7 towards 14, it is basic. This is simply what you need to remember. Now let us perform an activity to understand this in detail. Now here in this figure, the color gradation is given for various substances. We are going to take the solutions of various substances and check it with the universal indicator. The universal indicator is a mixture of several indicators. It is used to know the quantitative amount of hydroxyl or hydronium ion present in the solution. Now let us see the pH and the color range of various substances. Saliva before meal will give light color, light green color. Will give light green color and the pH is approximately 7.4, means it is basic. If we see saliva after meal, it gives light yellow color to the pH solution and its acidity is 5.8 and is acidic in nature. Then we have lemon juice, which is pink to red in shade and it is 2.5 and is acidic. Then colorless aerated drink are giving light yellow color and pH is 6.0, which is acidic. Then carrot juice gives light orange color and shows pH 4, means it is acidic. Coffee orange yellow and it is 5, so it is acidic. Then dark orange with tomato juice, which is 4.1 and is acidic in nature. Then we have green, that is 7, which shows neutral, and dark blue, that is 13 to 14, which is basic. Then you have red 1.0, that is acidic in nature with HCl, which is highly acidic. So you can see these various substances when they are tested with the universal indicator, you can easily measure its acidity. Now the pH of some common substances are given in this chart as well. You can see gastric acid, which is also HCl. Here the concentration is different, so they have a little bit variation in the pH. Then lemon juice, pure blood, milk of magnesia and sodium hydroxide, which is the highest basic substance. Now, the strength of acid and bases depend on the number of H plus ion and OH minus ions, respectively. If we take hydrochloric acid and acetic acid of the same concentration, say 1 molar, then they produce different amount of hydrogen ions, and so acids that give rise to more H plus ions are said to be strong acids, and acids that give less hydrogen ions are said to be weak acids. Can you now say that weak and strong bases are? So we can easily measure the strength of the acids and bases. You can say that HCl, HNO3, H2SO4 are strong acids. HCOH, CH3COH, HCN are weak acids. Similarly, NaOH, KOH, CaOH twice, etc. are examples of strong bases, and NH3, NH4OH are weak bases because the concentration of H plus and OH minus is different. So you can list the various strong and weak acids and bases. So, acid, strong acid, weak acid. Strong acids, few examples are HCl, HNO3, H2SO4. All synthetic acids are strong, whereas all organic acids are generally weak. And when you talk about strong bases, it is NaOH, KOH, CaOH twice, etc. And we have weak base NH3, NH4OH, etc. So you can easily understand what is the importance of concentration of various H plus and OH minus ions in the acids and bases. Now let us see how pH is important in our daily life. Are plants and animals pH sensitive? Our body works within the pH range of 7 to 7.8. Living organisms can survive only in a narrow range of pH change. When pH of rainwater is less than 5.6, it is called acid rain. This acid rain flows into the river. It lowers the pH of rainwater. The survival of aquatic life in such a rivers becomes very difficult. So the animals and plants are pH sensitive. Acids in other planets. The atmosphere in the Venus is made up of thick white and yellowish cloud of sulfuric acid. So can life exist there? Obviously not. Now what is the pH of soil in our backyard? Plants require a specific pH range for their healthy growth. To find out the pH required for healthy growth of plants, you can collect the soil from various places and check the pH in the manner described below in the activity. Also, you can note down the plants and growing in the region from which you have collected. You will see that the pH of the soil is generally from 6.5 to 7.3, and it is a good pH. The farmers add lime CaOH to the acidic soil to neutralize it, while the neutralized basic soil then add gypsum CaSO4 2H2O to the soil. Now let us see importance of pH in the digestive system. It is very interesting to note that our stomach produces hydrochloric acid. It helps in digestion of food without harming the stomach. During indigestion, the stomach produces too much acid and this causes pain and irritation. To get rid of this pain, people use bases called antacids. So, one such remedy must have been suggested by you at the beginning of this chapter. These antacids neutralize the excess acid Magnesium hydroxide, milk of magnesia, a mild base, is often used for this purpose. So you can see that how pH affects the body and the digestive system. Now change in pH caused of toothache. Now toothache starts when pH of the mouth is lower than 5.5, that is very acidic. Tooth enamel made up of calcium hydroxyapatite, a crystalline form of calcium phosphate, is the hardest substance in the body. You can note this down that your teeth enamel is the hardest substance in the body. It does not dissolve in water but it corrodes when the pH in the mouth is below 5.5. Bacteria present in the mouth produce acid by degradation of sugar and food particles remaining in the mouth after eating. The best way to prevent this is to clean the mouth after eating food. Using toothpaste, which are generally basic for cleaning the teeth, can neutralize the excess acid and prevent tooth decay. Self defense by animals and plants through chemical warfare. Have you ever seen stung of a honeybee? Bee stinging leaves are acid, which causes pain and irritation. Use of mild base like baking soda on one of the stunk area gives release. Stinking hair of nettle leaves injects methanoic acid causing burning pain. So the plants and animals both can be acidic. Nettle is a herbivorous plant that grows in the wild. Its leaves have sticking hair, which causes painful stink when touched accidentally. This is due to methanoic acid secreted by them. A additional remedy is rubbing the area with the leaf of dock plant, which often grows besides the nettle in the wild. Can you guess the nature of dock plant? So next time you know what to look out for it if it accidentally touches a natal plant while tracking. Are you aware of any other effective traditional remedies for such stink? You can find that out from the nature study. Now, here is a list of various natural sources of acids. Vinegar is giving us acetic acid, orange, citric acid, tamarind, tartaric acid, tomato, oxalic acid. Sour milk, that is curd, has lactic acid, lemon, citric acid, and stink, methanoic acid, nettle stink, methanoic acid. So these are the various ways in which the pH scale or the pH helps in the day to day life. Next, we are going to understand more about salts. You can complete doing your in text questions after the understanding of this chapter. Thank you.